All right. Good morning, good afternoon, good evening. Thank you for joining us today. I'm just going to quickly ask if everyone would write in real quick if they are able to hear me. All right, raising hands. That sounds good. Sounds like you guys can hear me. All right. All right. Today's webinar will be on accelerating your continuous delivery with Jenkins. We'll be speaking more specifically with ReadyAPI in that case. And today's presenters, myself, Dan Giordano, I do product marketing for the ReadyAPI test suite, and Stephen Colon with me today, our solutions engineer for both SwaggerHub and ReadyAPI, kind of our whole API side there. Just a little bit of housekeeping. This class is being recorded. And if you could just add your questions to the QA box, we'll keep them out of the chat if the chat's enabled. It might not be anymore though, hopefully. And then we do have a couple survey questions. So just be sure to fill them out and help us get some actionable data. All right, so quick introduction to SmartBear. We're a Boston-based company with 8 offices globally that focus on creating solutions for developer, testing, and operations teams to help them instill quality throughout the entire development lifecycle. We were founded in 2009 and continue to add products to our portfolio, including the wildly popular open source tools like SoapUI and Swagger, and our newest additions to the family in cross-browser testing a little over a year ago, 2 years ago at this point, and then hip test, which is a really recent addition. We create quality assurance and design tools for the entire software delivery lifecycle. But today we'll be more focusing on the bottom section here. But you see here we have on our y-axis UI and API, the layers of the application, and then on our X we go from dev, test, and operations throughout the entire SDLC. And this morning, this afternoon, we'll really be focusing on the ReadyAPI suite. Just a quick intro or quick kind of a reminder. We are having our SmartBear user conference that's happening October 29th and 30th. You can find more at the address listed, smartbear.com/connect-2018. This was an amazing experience last year with great speakers and customers sharing their years of insight and knowledge with everyone else there. This year we'll be right downtown in Boston at the Marriott Copley, so be sure to join us. You can purchase a ticket there at the SmartBear Connect website. All right, so today's agenda. I will throw up a quick poll, and then we'll kind of talk about continuous integration overview, a little bit about test automation's importance in that cycle, and then API testing best practices moving with Jenkins as well. And then we're going to get right to a demo, and we'll be able to see ReadyAPI being deployed in that pipeline. All right, so first we'll talk about what is CICD. And CICD is a process of continuously integrating and deploying new code into an existing database. They're usually set in conjunction, but we've actually found that it's pretty often that only one is happening and not the other. We're still getting to that point where we can consider ourselves full DevOps and fully able to integrate and deploy at one time. But by merging small snippets of code, we have less chance of causing bugs during our integration. When bugs are caught during the integration process, it forces root cause to maintain isolated. We know exactly what happened, and we're able to fix that quickly. And while the terms are somewhat used interchangeably, I think if you look around enough on the internet, there are slightly differences between the three. Continuous integration does not at all deal usually with delivering the application to production. It really only deals with getting new code into the master branch of a repository early and often. When that code is pushed, the application or the service is packaged up, built, tested, and then deployed on the test server. Your entire testing suite, as we'll talk about, should then be run at this point, at the point of integration. But again, we're not really deploying that source code to our production server. Continuous delivery is kind of the first level of getting the product into the hands of users often, but the actual act of deploying is held to a manual action. So we might be perfectly ready to deploy, but the actual deployment is done with a press of a button, maybe by a release manager. But there's usually some indication of manual work done after the integration phase. And then continuous deployment is the combination of both of those, where we're actually deploying to production in entirely automated fashion. So as soon as I write in my terminal, git commit, and leave a nice detailed message, Jenkins starts the entire process. If all the tests pass, the new master branch replaces the current on the remote origin, and there's just no human interaction going on after that process itself. Everything is done with code in an automated fashion where you're hands off. The continuous process is absolutely perfect for Agile, right? In fact, some say it requires Agile. There's lots of debate whether CICD precedes or chicken follows the egg. But Agile's call to rapidly iterate and get feedback often is perfectly complemented by a strong CI/CD pipeline with sufficient automated test coverage. Regression tests at multiple layers of the product can be a huge time saver when deploying code often, as it'll make sure the core functionality of the current working version is not broken. This is something that is huge. You iterate quickly, you get feedback quickly. Continuous integration can help you get that feedback. So everything we just kind of talked about sounded really fast and continuous, and that's great, but we really didn't talk about testing yet. And at the end of the day, testing has always been the bottleneck, right? It's always been the source for kind of a time constraint. It's always been the source of pain for those QA testers. So we can't leave out testing here. We need to automate our tests as much as possible at multiple layers of our application for maximum speed. API tests are fantastic, as we know, because they test a tremendous amount of functionality while running very quickly. We have the advantage of running 5, 10, 25 times faster than traditional UI tests that have to load up a browser, click around, wait for network connections that are lengthy. An API test is very quick to the point, and we're able to get feedback quickly. And you can see here that unit tests, integration tests, and end test, acceptance tests, and even load testing here. This is all the time-consuming part of this process. Everything in the build, you can usually build a modern application pretty quickly. PHP, everything is compiling quickly. Integration, release management after the fact and actually into the branch also happens quickly. But it's the running of unit tests, it's running of the integration tests, all your regression suites. That is where time happens. So if we can automate that and crunch that down, we can certainly accelerate our delivery. And here's, again, a recap of some of those benefits of automating. We get a faster development cycle. So we're able to actually deploy value to customers quicker. We're able to get to market there without hanging up and releasing on a monthly cycle, maybe a quarterly cycle. It also truly allows us to increase our test coverage. At the end of the day, there's always a finite amount of time to test the product. And with teams mainly running manual testing, there's just not going to be able to have sufficient test coverage. Edge cases come up, you're just going to be able to only do strictly happy path testing. Automation actually helps us achieve an increase in test coverage without a true increase in time taken during the testing phase. And then lastly, we're getting instant feedback to our development cycles. You can spend all morning on a new feature, and then within 5 minutes of checking that new code in, you can have instant feedback across multiple layers. It also helps as well. We all know writing code is difficult. Catching a bug that from a piece of code you might have written 5 weeks ago, it's difficult to track down. It's difficult to really understand and get context. It's always nice to know that the code you were just working on, that feature you were just working on, you're going to get instant feedback quickly in that sense. All right, so now to the star of the show. We'll now kind of just talk about, we've talked about CI, right, continuous integration and delivery, but we'll shift our thinking to an actual server, an actual tool. And that tool that we'll be talking about today is the most popular CI server, and that's Jenkins. Jenkins is an open source CI platform, which is nice. It's free. It's widely used. And it helps execute tests in an automated fashion, or not even just tests, help execute tasks in an automated fashion throughout the pipeline. It was actually formerly known as Hudson, but it was officially forked from Sun and Oracle in a project in 2011 and became Jenkins. Oracle saw that Jenkins was getting, or Hudson at the time, was popular. It was being built at the time by Sun Microsystems, I think. They purchased Sun Microsystems. They brought in Hudson. They wanted to put their name on it. They wanted to take it out of the open source community. And of course, the open source community fought back. They went to court and they settled on Hudson going to Oracle and a fork beginning as Jenkins. And today, Hudson has about, I want to say 26 maybe stars and 13 committers, and Jenkins is one of the most widely used open source pieces of software in the world. It's also built on thousands of plugins. That's a beauty of Jenkins. It's really a nice open source kind of framework for getting your tasks executed. Many tools that are built around the DevOps chain will have plugins for Jenkins, including ReadyAPI, which we'll go over today. And I just want to give a brief kind of shout out here. Jenkins is certainly not the only CI platform. There are many other fish in the sea. Here we have CodeShip, TeamCity, Circle CI, Go. Circle CI is actually, and CodeShip, some of these are actual in the cloud and based and executed in the cloud. Bamboo is built by Atlassian, Travis CI. These are some of the more popular CI servers you'll hear about. You might be using them, in fact. But we'll be talking mostly about Jenkins today, as it is kind of more widely used open source of the bunch. All right, so Jenkins is organized by projects. Jenkins have projects that are templated and can help you out move quickly in your pipeline. But you can see here we have Freestyle project, we have a template for a Maven project, Bitbucket integrations, GitHub integrations here. But this is great, and it gives us kind of a base layer to start at. Another cool thing about Jenkins is actually a new update that came out, I want to say in the spring of 2016, maybe in the spring of 2017, but that's called Blue Ocean. And it's a new Jenkins UI. It's kind of a visual pipeline editor, and it really makes kind of what you're doing in the pipeline come to life. So you can see here on the left, this is kind of our build one. We're able to go in and see the steps if we actually go into the build information, and we can edit. On the right is an example. We'll actually dive into a little bit more after this, but you can see it's beautiful in relative to the one on the left, but we have a nice modern UI that helps us kind of visualize our work. And this is a ReadyAPI example pipeline. So we'll start on the left here, and we'll actually go through one more that has some more kind of detail, but this is exactly what you would see in Blue Ocean. We have our functional tests on the left. That's going to happen first, all the way in the ReadyAPI functional with SoapUI Pro. Then we're going to run performance tests with LoadUI Pro, and we'll run that on the API layer. And then we'll actually run security tests against that. And then we'll end with virtualization. So we'll stand up the actual API we have and have that ready to go in our pipeline. And this is a deeper look here. We'll start on the left with SwaggerHub. SwaggerHub is our API design and documentation platform. We'll edit our API within SwaggerHub, reusing components, which are fantastic. And then with a simple integration, we'll take that Swagger spec, that open API spec, and we'll push it to Git. We have an awesome GitHub integration there, and that will start kicking off our Jenkins pipeline. Jenkins will listen to GitHub, and it'll see that the repo has been updated, and then we'll start our sequence. We'll first run our unit test against the code. Then we'll package all of our code up, our source code, and actually have a buildable application here. We'll deploy it in a microservice in this case. In this example, we're going to test the API layer first. Why do we do this? We do this because if the API test layer fails, we'll just go simply back to the drawing board and fix our bugs. We won't waste time in standing that full application up. Sorry, guys. Standing the full application up and actually getting to the UI, we'll just get the fastest feedback time possible. If the API test pass, we'll go to the UI layer. So here we'll deploy our API in a Docker container, a small piece of, a nice piece of software that we can stand up our API in seconds. And then we'll run our API test against that API that stood up. We'll run SOAP UI tests against it. We'll run load UI tests against it. And again, if all those pass, we'll move on to the UI layer, where we can then deploy the full application to something like Amazon Web Services or Google Cloud Platform, where we can actually have a UI. We'll run Selenium tests, test complete, test left, cross-browser testing. All these tools we can then use on the front end and do end-to-end testing on our full application. And this is all being automated seamlessly by Jenkins. Once we're actually into the wild and we're ready to go, we'll have Alert Site monitor our application, making sure that performance doesn't degrade and that users are getting a nice experience. One of the really cool features of Jenkins is a rollback API. And what that allows us to do is, with Alert Site, we can set an SLA in production. Let's say after 10 minutes, our APIs start making longer calls, over 200 milliseconds. We can actually signal to Jenkins to roll back our previous version of the build, which is really neat. It's a way where we can feel confident deploying continuously because we know we're able to roll back immediately. And just here's some Jenkins best practices. When we talk about Jenkins, we always should be using a source control management tool that kind of go hand in hand. SEMs can store your code, your scripts, all your configuration files. All of that can actually be stored in GitHub and then used in your Jenkins pipeline. Also, tools like GitHub Auto Status plugin, it's just a great little plugin to actually get some data back on your builds. Also with Jenkins, use parallel builds to speed tests and build execution time. This is certainly applicable on the UI side, but we always want to be maximizing our test execution kind of ability. So what does that mean? That means firing up multiple nodes underneath our Jenkins so we can run 10, 20, 30 tests at one continuous time. Another, run unit tests and even static analysis as part of your pipeline. A lot of developers will actually run their unit tests and do static analysis on their own feature branch before they even integrate. So they'll run that, they'll have their unit test suite and they'll run it manually after they do some work. But we definitely recommend running that unit test suite as part of your pipeline process. Stick it in Jenkins and run it every time you integrate. And then lastly is try to provide realistic testing environments as much as possible. Jenkins is a server. It's not standing up your application. You need to give it the best, most realistic situations for you to test in. So we have tools like Service V Pro that can help you virtualize your assets and create realistic API testing environments and UI testing environments. And then we have tools like cross-browser testing, which can help you with your device lab. So run against real browsers, real mobile devices. But that's all in trying to push us to provide the most realistic production-like environment during our continuous pipeline. And at this point, Stephen, I am now going to turn it over to you. All right. We will look at some of the stuff we talked about today. We'll try to replicate some of that ReadyAPI pipeline, and we'll see what we can do.
Yep, that sounds great. So let me go ahead and...
Let me stop sharing. All right, you should be able to share now.
Give it a second there.
All right.
Great. So yeah, let's actually start looking at some of the tools that go behind this Jenkins pipeline and how we can utilize it to really speed up this API testing process. The first tool we're going to look at is ReadyAPI, and this is where all of those different products that Dan talked about, the load testing, the functional testing, security testing, virtualization, all sit under this one platform called ReadyAPI. And that's SmartBear's offering to assist our customers with their API testing needs. So on the right here, we can see the 4 different products. We're mainly going to talk about SOAP UI Pro. I'll have a functional test here that I'll talk about where we test our open weather API. We'll talk about how SOAP UI Pro lets me leverage functional testing so that I know my API is behaving properly, it's responding properly, and then how easily I can then build it into a centralized Git repository and then have it pulled into Jenkins as well. Then we have Secure Pro, which is our security testing product, where with a couple of clicks, you can take all of the endpoints you were using in SOAP UI Pro and start security scans against them. You can check for vulnerabilities that may occur because of SQL injections or fuzzing scans or cross-site scripting. There's about 8 different scans made with the OWASP top 10 security threats in mind. And it's just a really good way to look at your API and from a security perspective, get a report on any possible vulnerabilities so that you can take it to your security team or your developers, and you guys can work on making sure your API is as secure as possible. Then we have Load UI Pro. This is our load testing product that we offer in ReadyAPI. With 3 clicks, you can reuse your functional test cases from SOAP UI Pro to build load tests on top of. This means that I no longer have to rewrite API calls twice. I do everything in SOAP UI Pro in terms of writing the API calls out and writing my end-to-end workflow. And then I can import it into Load UI to start load testing and only focus on configuring the load test with our easy-to-use scriptless UI. I can then gather my own statistics, either in table or chart format, monitor servers like a Windows or Unix server, or monitor databases like Oracle or MongoDB, so that I see any server statistics of how the CPU of these different servers are running. So we get more of a holistic load testing perspective. And then we also offer a very ease of use distributed load testing framework. So a lot of our customers, at some point they start load testing, they may need to start load testing to the range of thousands of concurrent users. And a single machine, a single Windows machine may not be able to run that. So in Load UI Pro, we offer a very easy to use free piece of software called the Load Agent, where you can then connect to any machines, either in your office currently or in the cloud. We have integration with Amazon EC2. We have an AMI that you can use and distribute your load tests there so that you're using the resources of many machines, but this machine will still gather all of the statistics. And again, this is all within the UI and really where the value of Load UI Pro comes from. Lastly, we have Service vPro, which is by far one of the products that have one of the most flexible use cases out there. Service virtualization is something that's interesting within the ReadyAPI platform that can let you eliminate any bottlenecks that you or your company may see because of these dependencies. These services that are either third party or they're within your company just on a different team. You can virtualize any assets, be it REST, SOAP, JMS, or JDBC, so database transactions, easily using our route and record functionality. So without building out the business logic myself, I can take something like the Slack API, which maybe my company's building on an integration for. I can virtualize a part of the Slack API using route and record so that I can then test against it and build out my integration without having to actually use the real API yet. So it could really speed up that time so that I can just focus on my work as opposed to third-party dependencies. So there's quite a few use cases there. And one of the interesting offerings that we've wrapped in with our testing tools to really give the power to the testers over whether or not their services work in a certain way. So now with that, let's go ahead and look at the Open Weather API test case that we are going to build into Jenkins here in SOAP UI Pro. So in SOAP UI Pro, I have my project, I have my test suite test case, and at the very bottom, I have my functional tests for this weather API. Now, to anyone that's not familiar, SOAP UI supports end-to-end functional testing for your API. Now, that can mean a couple of different things, but what what we see is that you can really test out every part of your API, mapping user interactions within your API workflows so that you can then make sure that at every step, your API works properly. So here we have a city's data source, which pulling from an Excel file will go ahead and iterate through several different city names. It'll take it into an API call, which will then run. This API call has validations against it. And as it iterates through, we're going to see all these different city names. It's going to go ahead, give me, sort of a pass fail response and a really good look so that I can, at the end of the day, say my API is functioning properly. So now to build this into Jenkins, there's a couple of things involved. First, building it into a centralized repository. I don't want to have to copy and paste this project into several different nodes, maybe have some inconsistencies, some of the common challenges that people face when they don't use a source control management system like Jenkins. So in SoapUI Pro, we have a Git plugin that is available and supported by us so that I can take this project easily and bring it into a shared repository. So if we look at these options below, I can commit the changes, see any history, revert back, even switch branches. So if I'm working with a team of people on an API test and then ultimately building it into Jenkins, I can leverage Git source control so that we're all working on one project. It's consistent, and Jenkins always has the most updated project when I kick off the test. So that's how we support, going into a centralized repository. Now, to actually run the test, instead of opening up ReadyAPI, which is a UI-based application, you can utilize something we built in the backend, which is Test Runner. This is a command line tool that'll let you take all of the functionality that we're seeing here and run via command line. In the UI, we can look at the different options Test Runner offers. There's over 20 different arguments, so it's quite a lot to keep straight. So you can look at this UI, look at what test suite test case you want to run, what environments you want to run against, what reports you want to generate. And once you've decided these different factors, you can get the command line from ReadyAPI so that you can then copy it to your clipboard and put it into Jenkins without having to know which arguments map to which functionality. So this is how you can easily go ahead and just build it into Jenkins. Once you've understood like the end-to-end testing, you've built out a really nice regression test suite, you go ahead and take this command line and you build it in. So that's ReadyAPI in a more overview, high-level kind of sense, and then digging deeper into SoapUI Pro and how we're going to build in the functional API test to our pipeline. So now let's talk about the other piece, the other tool that is quite important for this pipeline, which is SwaggerHub. SwaggerHub is where our Swagger definition for the Open Weather API will live. And it's going to integrate with our Jenkins, with our Git repository and ultimately Jenkins so that I can make any changes to the definition. And then it's going to kick off the Jenkins pipeline that we're going to have a look at that I've built in my API tests automatically. Once those tests pass, it'll deliver the updated API into a space where we can look at its documentation, and we'll have a look at that as well. So SwaggerHub is another product that we've developed here on top of the Swagger open source tooling so that teams can collaborate efficiently on building out these Swagger specifications. So what we're looking at here is the SwaggerHub homepage where we have our API catalog. These are all the APIs that I can either work on or just view. On the right, I have my different organizations that are available. So I can actually, for our larger customers that have tons of different APIs, I can manage different organizations, each with its own set of projects, so that as I'm looking through my different APIs, they're not just a jumble of APIs in a single catalog. there's actually some organization to then look at your APIs based on services or the projects that they fulfill and navigate through them very easily. Once we go into an organization, we can actually start having a look at the open weather API. And this is where I can actually make my change. And I've set up the Git integration where it'll update the specification, send it off to the Git repository, and Jenkins, which is listening to that Git repository, will kick off a new build because it saw this change. So just to orient yourself a little bit into SwaggerHub, since you guys may be unfamiliar, in the middle, we have our editor, where we have commenting and auto-completion functionality. Commenting so that as a team of 10, 15 people or more are using this, they can leave comments so that as they develop, they'll have a system of communication within our product. We also have auto-completion so that as you're writing your Swagger specification, if you're not as familiar with Swagger as much, you can just go ahead and use our auto-completion to look at the different objects that are available, maybe put them into the specification and fill them out and see what you get. You can really sort of explore what the Swagger specification offers. On the left, we have our directory, which as I build out this API, currently there's only 4 operations and 2 models, which is not a lot. But as I build out my API, I can go ahead and navigate very easily between each operation in the editor so that if it's quite long, I won't have to scroll through it. And then on the right, we have our UI. And this UI is where our consumers can come in, look at the API that's available, look at the different operations that are available, and then actually try out some calls with that API using our try it out functionality. So this is where our documentation piece comes into it, where I'm going to build it into an automated pipeline, but at the end of the day, once the build is done and it's sort of pushed on to a more public space, those consumers can come here and look at the documentation at the very start of this huge pipeline so that they have the documentation, they get a really good understanding of what the specification does so that they can use it in the most efficient way possible. So now, once I have my specification written, I've integrated with GitHub here where I've sort of connected to my account and chose a specific repository. We integrate with a lot of different source code management systems. So we have things like Bitbucket, GitHub, GitLab, and then we also have integrations with API management systems. So while SwaggerHub just focuses on the collaborative design of these Swagger specifications, we integrate with these sources so that we can still have very efficient pipelines that lead into implementation. So I can take something like the Amazon API Gateway and integrate with that directly so that any developers can implement the API using Lambda Sync once I submit any changes into this integration. So now with the GitHub sync, we're going to make a change here and be able to see it happen within our pipeline. So let's go ahead and I'm going to sort of change this. I'm going to make a very obvious change just so that we can see it. I'm going ahead and save it, and it'll take a couple of minutes to kick off as it sort of goes into the repository and then comes back down and Jenkins runs its pipeline. And what we're going to see here is this pipeline kicking off where we have our build step. Once it's starting, it'll start building the application. Our test step, which will have already API tests using the command line that we saw earlier. And then ultimately, it'll deliver into a space where I can then look at the change from a specific port that anyone at my company can access. So now if we go ahead, I'm just going to sort of let this sit here. And as this sort of goes on, we should be able to see in a moment the build running. So while we're waiting, let's go ahead and talk about Jenkins specifically. So as you saw, we offer a command line tool, so we can actually tie to any CI/CD system that's out there. The reason we're showing Jenkins, like Dan said, it's one of the more popular builds that are available to everyone because it's an open source tool built on thousands of plugins. That being said, we've also created a native integration into Jenkins so that we can now see how to build these test runner commands from text fields as opposed to copying and pasting just raw command line. So if you look at this example here, you can see that instead of copying and pasting a command line, I'll get these different fields where I'll point to my test runner, my SOAP UI project, my test suite test case. And it's just a really good way to bootstrap my test runner without having to copy and paste command line each time. So now let's have a look and see if something kicked off here. Sometimes it takes more than a moment, but we can see it's starting to kick off. It's pulled from the repository where SwaggerHub updated it. It'll now sort of go through, it's on a Node server, so it's gonna go through an installation process on Node. We're gonna see then it's gonna build out tests and then ultimately deliver, where this endpoint will actually stand up and show us updated documentation for the Swagger Open Weather API. So let's see here. Okay, we can see the build has finished. It's kicking off the shell script, which is the command line for the ReadyAPI tests. We see it's executing that test, and then it shuts down. And once that's done, it'll go into its delivery phase, where now it's delivered into actually deploying the application. If the tests failed at any point, if the API wasn't acting as we expected, we would have got this pipeline chopped off at the test phase so that we don't deliver a faulty product. So now when we look at the Swagger UI, we can, when we look at our applications endpoint, we have this docs endpoint where we can see sort of my very obvious change that I just made for demonstration purposes. I can see the different actions here and then go ahead and start using this. So any changes that were made, I can go ahead and start using this. And like was said earlier, it's very instantaneous, where I can now rest assured my API is working properly. It's delivered now into a space where other people can use it. And now we can actually start using it and put it into a production environment. So that's the Jenkins pipeline and how we can build out a pretty robust system. I only did it with SOAP UI Pro for our security testing and our load testing and our virtualization. It's all very similar, where we have command line tools that let you do all of those functions without the UI. So you can build that in a very similar way to the way you would build your SOAP UI test cases into this. Now, the last step that we saw in our pipeline was then monitoring an in-production API. So to finish off this demonstration, to really paint a clearer sort of end-to-end picture, once your API is brought into a production space, we can then use AlertSite to either import our SOAP UI tests or import the Swagger definition directly and monitor this API using AlertSite's real-time synthetic monitoring solution. We can see here I'm monitoring the Open Weather API. I can see throughout time, I sort of got a bunch of passes. I got one failure in the most recent test. I can see that very clearly. And this is just a really good way to understand whether or not your API failed in a way that your functional tests, your load testing may have missed before your customers actually see it. So it's a great way to catch it so that if you have any business critical APIs, you can make those fixes a lot quicker, build it back into this pipeline, retest it, see what is going on before a customer actually sees it. So that's the demonstration going from SwaggerHub to design your APIs, to ReadyAPI and SOAP UI Pro to actually test your APIs, then using Jenkins to tie them all together into this very easy to use automated pipeline, and then AlertSite to then monitor it once it's in production. So, if there's any questions, let's go ahead and I'll switch it back over to you, Dan.
Yeah, you can keep the screen actually.
Oh, sure.
Pull it back up just in case we go through it. All right. So actually, one of our first questions deals with data, and it's interesting because I have a solvent for it, I think. They explain, so far I've been noticed test data is a big challenge in testing. Most of our test scripts are getting failed. My question is, if we integrate our test scripts into a CICD pipeline, we may see a lot of failures which cause build and deployment starting from the test data itself. How can we overcome this issue and this methodology? I actually think one of the great ways to overcome test data problems is with virtualization.
Mm-hmm.
And that's because you can control the response of the data and what it gives you. So you're still testing the logic, you're testing the actual functional aspect of the API, but you're able to use your own mock data set on the outset. So you can run your automation tool, and when you select Boston, every time you can expect for the temperature to stay static, let's just say in our open weather, and we can mock that and say 75 degrees. We can give it another city and another degrees, but we can kind of fake the data, again, not on the test data side, but actually on the virtualization response side.
Yeah, I completely agree with that. And it's also about controlling when your data is available too. So if you're using any third-party systems, you're going to have to trust that company has that data available at any moment. It might not happen. And like you said, it'll go into your pipeline. You'll see all these failures that aren't your fault. And then you'll have this failure to deploy. So yeah, that's a key point of where virtualization plays in this API space.
Can we verify payload data values against database values?
Yes, you can. So SOAP UI Pro has support for any database that has a JDBC interface. This includes, all of the big SQL database providers. So there's quite a few different options. And you can go ahead, make your API call, make your JDBC request, which is a SQL query, and then compare those two values. Make sure that your API isn't maybe translating your data incorrectly, or whatever's coming from the database is correct to begin with. So you can verify those two and, not just have a look at your API, but also the database that's behind it.
And another question from the same user. Is this compatible with Microsoft TFS?
So what does TFS stand for again? Do you know?
Team Foundation Server.
Oh, okay. Yeah, just make sure I'm talking about. There's so many acronyms out there nowadays.
They have VSTS, they have TFS.
Yeah.
They're all trying to make new tools while keeping the old ones going.
Yeah. So many things out there. So yeah, with TFS, it is compatible because it's a command line tool. So that's one of the key things that I like to stress about our automation support is that we don't tie it to a specific system. We're showing Jenkins for this webinar because it's popular. But if you're using TFS or TeamCity or Bamboo, you can very easily build these command line test runner commands into them so that you can automate with whatever system you're using today.
All right, we have some more questions, it looks like. If anybody else has any, feel free to ask. I'm going to launch a poll right now, though. It's a couple questions. Everybody, please participate. I'll put up the answers after so everyone can see. It's always fun seeing what everyone else thinks. All right. Getting some good votes. Just a couple questions. Oh, actually, it's like a quiz today. All right, we'll give it 10 more seconds, I think. All right, I'll end the polling. Share results real quick. All right, so we have a fair amount of people responsible for both sides of the house with API and UI. 61% using CICD now. A fair bit of you not familiar at all with any CICD pipeline, but the majority familiar with Jenkins, which definitely makes sense. We see most people using Jenkins, I think, because it's open source nature. And quite frankly, it's a great open source framework for CI, CD.
A lot of stuff in there.
Exactly. And Blue Ocean was an awesome addition. I think more and more products are coming out and trying to support Blue Ocean, not just the classic view, but it's been really cool. All right, I'm going to stop sharing results here. All right, it looks like we are out of questions, and no one has anything else. So I think we're going to end it. Thank you, everyone, for attending today. Stephen, thank you for that awesome demo. We hope everyone starts taking advantage of API testing in any CI/CD platform, but start continuously testing your application. All right, enjoy the rest of your day.
All right,
Thank
have a
you.
great day.